Okay, so I gave him back some homework, and we are all ready for the, I think we've done all the material, we've covered all the material in class, the lecture material for the exam that we have coming up on Monday. And we're going to spend today seeing if you have any questions about the last homework assignment that's due today. And then after that, we will start reviewing for the exam.
We just do it.
Just do it? No, I'm not going to just do your homework for you. But are there any questions about it? So what did you have? 14.38.1 and 14.40? Is that what it was?
Yeah, it was on the.
And the
Whatever S.18 was, I got.
Yeah, and there were one of them I had just fill in the blank. I mean, I gave you the
That's the one I got.
the hints,
Yeah, I got
and you fill in the blanks.
Yeah.
Is that one okay? Did that one work all
No,
right?
the fill in the blank ones I didn't.
Oh, the fill in the blank was
I
hard?
got the other one, but I didn't get this one.
Oh, and that was 14.38.1, right? Alternate definition of total?
Interpretive decisions that would really change the way it comes out.
I don't understand where the B is an element of B equals true came in. 'Cause I didn't get that
Because it
anywhere.
is.
But where is that in here?
Well,
Because B is.
it's for all, but yeah, it's type B, right.
Yeah.
You understand that these are two, look, oh yeah, actually that's a good question. Let's, right. Look, if you say B, little b, type B, look, if you say little b is type B, that's the same as B is an element of big B. Because a type is just a collection of values.
Type where you put that in the range.
Yeah, yeah. So if you do this, if you say star. Oh wait, can we do this in general or? Yeah, it is. Yeah, you can do this in general, right? If you say star B, type B, range true, blah blah blah. This is the same thing as saying star B, range B is an element of big B, blah blah blah. I mean, these are the same thing.
In this, we had B as an element of B.
No, I don't really mean equivales because this is actually a Boolean expression which is either true or false, and this is an annotation. This is the type of this is B, but the type of this is Boolean. So, are you with me on that? So the type, it's always really, I can't stress enough how important it is. And I've been grading some papers. I'm still grading some papers where I have to circle and I say type conflict. I mean, anyway. So it's really important to keep in mind what the types are and what expressions are Boolean expressions and what expressions are set expressions, what are sets of elements versus sets of ordered pairs. If you got to keep all those types straight. But anyway, does this answer your question?
No, because
No?
I have like a quantification where I have range true and then body B is an element of F dot A equals B is an element of C. Is that not right?
And has he given back 14?
B.
For all.
Oh, no. Look, no. If you have something like B, hold on. If you've done something wrong, if you have something like this, B is an element of F dot A, this is definitely, there's a type conflict here. So you've done something wrong if you've gotten to this point. Because look, F dot A is not a set. This needs to be an element, and this needs to be a set of, the type of this needs to be a set. So if you have something like this, then something's wrong.
Well, okay, then I guess I'm confused on the second step when you replace B with A. So how
With BC, I have B comma C replaced by A of type B and C of type C. Right?
on the second one? Mine just says B replaced by A type B.
Oh, you're right. A C, well, yeah, C.
So I have.
Yeah. I have, yeah, you're right.
Okay.
You're
So I
right.
have B equals curly brace A type B range. There exists a
C.
Range true A F C.
Yes,
Well,
that's
then,
correct.
When you use the notation, doesn't that make it there exists a C range true F dot A equals C?
Yes.
And then when you use extensionality, doesn't it go there exists a C range true for all B type B?
Wait. Say that again. Okay, but now you're starting at the beginning. I mean, it's over the whole thing. It's for all B. You're going to do set equality on the whole thing. So it's going to be, so what do you have?
No, I have, okay, so for my for all loop shouldn't be inside my there exists.
No.
Okay. So
No, maybe that's where you went wrong. Okay, so look here, if you have, the steps should be like this. In that step, it should be B equals, capital big B equals, for, and then you have a set here, set A type big B, right? Is this what you have?
Yeah.
And then here you have, and exists a C, exists a C, and which is in big C, type big C, range true, and then you've got f dot A equals C, right? Is that what you have?
before this,
Is this not what you have?
no, that's what I had before this.
Yeah, this is what you had before.
yeah.
Now what I'm saying is the way you do this step, the way you use 11.4,
Wait, how do you get the type C?
I know, I don't have type C.
It's not on the equation.
well then,
Just make it
you
up.
don't need it, yeah.
Oh, I just added it anyway.
I mean, look, this is just type annotation. They're just annotating. That doesn't change anything, right? It's just for emphasis, because here we don't have little a as of type big A, or we're emphasizing that little a as of type big B. So I just thought I'd throw this in,
Okay.
but that's neither here nor there, right?
Okay.
Okay, so now whenever you do 11.4, it's over the whole thing, right? See, it's this set equals this set.
Oh,
So it's over the whole thing.
I did it just in the.
No, I see, that's where you went wrong. Okay.
Because then I was like, I don't know where we're getting B and B from.
Yeah. Okay. So and this is where this is where for all little b. See, because you have to use a letter, you have to use a variable that's not either A or C, right? So this is where we use, so what this is going to equal, by the hint that I gave you in the thing, it's going to be for all B, which is type big B,
Range, B is an L.
range, blah, 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 blah.
Isn't it range true?
Yeah.
It is range true. Range true, and then it's going to be blah, blah, blah. And you can fill that, and now you're on your way, I think, right? Are we good?
I got a question about the next one.
Okay, before we go on to the next one, let's make sure that, is everyone okay now on this?
So when we're doing the next step, the 11.5.1, we're doing it on the curly brace part.
Yes.
So that we're adding an A at the end.
Yeah, you just add an A as the bottom.
Yes, yes. Yeah, because that's an abbreviation. Remember that. Yeah.
Okay. And do we have to keep true in there, or do we just take it out?
You drop it out. Don't you?
I'm not sure what the question is, but if you say so.
When you say the element of B is true, do you leave the true there or do you drop it off? I left it there and I didn't use it ever again.
Well, you can leave it
Well, I
off
mean,
anyway.
you just, if it's true, then it's range true, right?
Okay.
Yeah, you can just drop it. I mean, why keep writing it down? But see, now there's going to be nested existential. Now you're going to have an exists within an exists.
Which is what I want.
Yes. Because, I mean, the theorem that we're trying to prove, which is 14.38.1, it's English, it's worded in English. Yeah.
Okay, for the 11.3 set, it says
Yeah.
membership with A, not in B.
It's a requirement.
Yeah, but how do you know that A is not in B?
How do we, so you're questioning the proviso?
Yeah.
11.3, set membership.
You say we can use it, but he wants to know how.
No,
How
I
do we know
I
that?
know how, but why? How do
You know how, but how do you know? Because, look, A is, because those are two specific expressions.
Okay.
One expression, the expression B
Is B.
is B.
Okay.
Right.
It's not A. A is not in the expression
So
B.
in this
The-
case,
in-
B is not a variable.
No. B is the expression, and A, you understand what I'm saying?
Yeah, because.
B is the expression, and A.
This not occurs, this F is an expression.
Exactly. And so B is the expression, and that B does not have A in it. I mean, that's literally, it's not a general expression.
Got it.
Ooh, that was a good point, actually.
Because F
Yeah.
expression or set.
Yes.
Because we have capital.
It is. And I was thrown off a little bit because notice that those are lowercase. So those are the actual expressions. I mean, A is the actual variable,
Yeah.
and B is the actual expression.
Yeah.
It's not, yeah. At first I thought, wait a minute, B, how could, but then it's an expression. Yeah. It doesn't occur in B
Got
textually,
it.
as opposed to being a set, anyway. Okay, are we good?
Set to these?
I
When can we
do.
get those tonight?
You will.
Okay.
Okay, now, did you say you had a question about,
Yeah.
Can you do the next problem for me?
no? Oh, that's a good question. That's easy to answer. No, I can't do the problem for you.
He doesn't know how.
I've looked at it.
So after the two hints you give us to start with,
Okay, so you started with F composed G dot B, right?
yeah,
And then you just,
you use the hints and you get down to,
then so you change that to a relation product, and then you use the notation thing, right?
yeah. So
Okay.
that's where you leave us. I
Yeah.
tried about 5 different ways to branch off from that point and never got one to
I used 14.21.
Well, exactly,
Can we do
14.21.
this in class on Tuesday?
I felt so happy when I did this, especially after I couldn't do the first proof.
Yeah, you did that, and that was good. That's what you do. You use the definition of relation product, which is there exists a C, right?
That was the first thing I did, but it didn't work out.
And then
Well, no, you should have done it. Okay, you worked that out, right?
And then you do notation again.
And it's the conjunctive meaning, right? So instead of doing B, G, C, F, D, you do B, G, C, and CFD, right?
After that?
No. Or do you want to give us a
I
hint
did
here,
it.
Ashley?
Just to see B, F, C, G, D.
Can I see it?
But then your conjunctive meaning, split it, make it an and. And once you get it in conjunctive meaning, and you have an exist, you're home free, because what can you do?
1 point.
Well, before you do 1 point, what do you have to do?
There's gonna be like a trade.
Yeah.
Oh, I
Cha.
Is that 9?
Just got really excited about that.
What? Yeah, that was a good one to get on your own, wasn't that? Wasn't that satisfying?
For the last one, the last step, is it, so F dot G dot B is the same thing as F of G dot B, just like the notation.
What kind of trading do we need?
919.
Yeah, F parentheses G dot B, yeah,
Okay.
equals D, which is what you were trying to prove, right?
Does it matter which one we put into the range?
Yes, it does. Because you want the C to
Yeah.
be replaced by G dot B.
Yeah.
So you have to change that.
The C, yeah, it has to be the C equals, because, the dummy, to use the 1 point rule,
Because you have to have G dot.
you have to have the dummy equal something to
Right.
use the 1 point rule. So there's only one way to do
You
it.
need C, G, D in the range?
Yeah, but you have to change it to be G dot B equals C. And your letters are mixed up.
Because back there you have, there exists a C. Is it B, G, C, F, D?
B, G, C, F, D, yeah.
Yeah. And by the way, I hope you're using a pencil there. I noted down
Yeah,
here.
for a while I didn't have a pencil, but now I restocked.
Good.
What's wrong with pen if you don't make mistakes?
You make mistakes. That's if the fault, if the antecedent is false, the
So you need
Math
B,
jokes.
G, C in the range?
right, math jokes. Logic, yeah, you're right. Pretty geeky humor here.
Absolutely.
We should have our own web page with logic humor,
That'd be a little.
with little cartoons and
That's not gonna
So which one do you put in the range?
Oh, t-shirts, yeah, that's what we could do. Oh, yeah, hey, we should have a t-shirt for this course, shouldn't we?
We should do the math equals equals not fun.
Do the proof on the back.
Yeah, yeah, do the proof on the back. Oh, my goodness. This is, we are you with me? The only problem is you wear something like that and nobody would, no one could appreciate. I mean, at least if you wear a t-shirt with something, it is, I'll be inside, yeah, inside joke. Yeah, there are 10 people who know the difference, who know, how does that work? There are, what's the binary one? There are 10
Kinds of people.
kinds of people.
Those who understand binary. And
Those who understand binary and those who don't. Well, in binary, this is 2.
Yeah.
11 cheers for binary.
Oh, that's a good one. I hadn't heard that one, but that's a good one.
I saw it on a shirt.
1 cheers for binary. Yeah.
I saw it on a shirt like just 2 days ago. one of your older computer science.
But that kind of humor is easy to understand because all you have to do is understand binary to appreciate that. Okay, are we good?
I still don't know which one needs to go in the range.
That's all you do, right?
Wait, what is this English?
Well, what do you think? Come on, you can figure that one
I
out.
still don't know how how 1 point rule is gonna help. So I don't know
Yo,
where I'm trying to
Look, the way the 1 point rule works is this. The way the 1 point rule works is this. If you have star, I don't know, x, and you have x equals anything,
Yeah.
right? So there's your hint.
I know how it works, but I don't
Well,
know
then
how
make it
it's
so that whatever is here, it's this equals this goes,
That's right.
trade so that,
I do some symmetry.
well, yeah, symmetry, x, you know that
something ends.
y equals z is the same thing as z equals y. I mean,
Yeah.
But, I mean, whatever your dummy is here, that variable equals something, trade that into the range.
That is the range, isn't it?
Well, yeah, but in the previous step, it's to get to here. Can you not trade that into the range? Do you not have a conjunction in your body?
Conjunction.
Well, can't you do a trade? How does trading work with existential?
You can just put it in the range.
Okay, but now you have a choice of which one to put in the range, right? Well, look here. Look.
Oh, I got it. Never mind.
Okay.
Can you remember the chart? The homework that I,
Yeah, we're going to do that. Yes, before we do that, I think I need to tell you what's going to be on the test.
that would be good too.
Okay. All right, so now here's what's going to be on the test. First of all, I told you, I want to remind you of this, but I told you this once before. This table,
Memorize it.
table 14, let's look at it here. Table 14.1. The first question will be to ask you, you need to know the property that goes with the name. So the first question will be without the equation sheet.
And you're just gonna give us.
And I'm just going to say, what is the property, write down the mathematical property or the definition of irreflexive or symmetric or antisymmetric or asymmetric or any one of those. So you have to memorize you have to memorize this. It's just rote memorization. Okay?
There's no property and the alternative.
No. I will not ask you for the alternative definition. You only have to know this property.
Wait,
Okay.
are you going to give us the property and then we give you the name?
No. I'm going to give you the name. No. I'm not going to give you the property and you give me the name. I'm going to give you the name and you write down the property. Okay? So just commit that to memory. Okay? Now, okay, so that's the first question. Then after you answer that question, I'll give you the equation sheet and the rest of the exam, and then you work the rest of the exam. Okay, so you have one shot. You can't come back and change your mind on this once you started the rest of the exam.
What if I have an epiphany?
Well,
That
then,
includes looking at the equation sheet.
yeah, have an epiphany after looking at table 14.1. Okay, so that's the first question. Now the second part, okay, and then the rest of the part is going to be proofs. Oh no, sorry. After that, there will be another question that will be short answer. And I'll tell you right now that those short answers, you know those tables, we had 2 exercises with tables in them. Those make perfect questions because they're so easy to grade. No, plus they are really good for you to think through what all these are with these example
We're gonna go
relations.
over that.
We're going to review this. Yeah, that's going to be part of our review, okay? So we'll have to think about that. All right? Now, okay, and then the rest of the exam is going to be proofs. Now you know, okay, now we're starting with, here, let's go back to where what we were started with. We did, at the end of the last test, we had gotten up through the if statement for our proofs. And since that, we have done the do loop, the do statement.
Is this the last test before final?
Yes, this is the last test before the final. All right, so you know that there's going to be a question on to prove a do loop is correct. Now here's the thing though, you guys. These are kind of long because it's a 4-step process. So I probably will not ask you to do all 4 steps. I'll probably just ask you to do 1 or 2 of these. Okay? So just because it's, you know, once you've done, it's kind of tedious. And once you've done, but you have to know how to do each, you have to know how to set up each one. So I'll give you a piece of code and I'll say, you know, prove that P is true before execution of the loop. Or I'll say, prove that P is a loop invariant. Or I'll say, prove that execution of the loop terminates. Or I'll say, prove that R holds on termination. And if I just say that, you should be able to, you'll have this, you know, with these steps, and you will have done it before.
Go over all this.
Yeah, and I think we should review, I think we should do one of these. We should start our review with doing one of these. And then after that, it's relations and functions all the way up through functions and inverse functions.
Where do
Okay?
we stop? Like, which thing do we stop?
I just said, we stop at inverse functions.
Yeah, we did that in Gotham, his thing?
Yes,
The one that I was in?
yes,
It's really simple.
Okay. Should I watch the video?
Yes.
yes.
Yeah, I talk a lot.
Yeah.
It's really cool.
That's what I was-
Watch the video because Ben talks a lot.
Wait, what'd you say, Ashley? No, you don't?
You can't hear what
Yeah,
you're
just-
saying.
Oh, I can hear.
Okay, so I guess it's up through 14 point, okay, Josh, it's up through 14.46, if you want a number.
Thank you. I do.
I have a question about the whole right and left inverse thing.
Okay.
I think it's on the previous. Where it's at? Oh, where is it actually defined? I guess.
I think it's on.
Here, 1443.
Yeah. Right.
How did we know from the proof we did in class? How did you know that it was the identity of C? That's what I was confused
Yeah,
about.
that's the big
Because
one.
I was guessing that it was going to be the identity of B.
Because the placement of G.
But how do we know what G is?
If the right inverse if G is on the right. If G is on the right, then it's the identity of the domain. If G is on the left, then it's the identity of the range.
But how do we know what G is?
Well, because it's G from C to B.
It's,
So you know that it's.
we did an example, and that's why we could like see that it was definitely the identity of C.
See, if you go from, yeah, F composed G has to be of type, has to be mapped to C. F composed G maps from C to C, and G composed F maps from B to B. Because one is the inverse of the other one, so it goes back to the same thing.
So then you're going from B to C and then from
F,
C to B.
yeah. Compose, yeah. Actually, that's a good way to look at it. Compose is product is
Product document.
Yeah. You remember the definition.
79.
Remember it's this. Remember it's G compose F is F product G. So it's going. So this is going from.
It goes from B to C by.
Okay, so here we're doing part A. So what we're saying is that G compose F is the same as F product C, F times, whoops, sorry.
Yeah.
G compose F is the same thing as F times G, F product G. Is that right?
Yeah.
Okay, but then F is going from, if F is from B to C, then that means this one is going from B to C, and then this one is going from C back to B again.
So you're ordered pairs.
So therefore, it's I sub B.
Yeah.
So this whole thing is from B to B.
So what
I sub B is the identity on a function that goes from B to B.
what defines it as a left inverse?
Well, G is the left inverse. What this is saying is G is the left inverse of F because it's on the left of F.
No idea what you're trying to say.
Can it only be an inverse if something?
Well, it's an inverse. G is an inverse of F because if you compose it with F, you get the identity.
Okay.
Notice G is total.
Yes, all of these are total. Both of those are total.
Don't they have to be?
Yes, inverses are defined for total functions. Okay, is everybody,
No.
you still don't, what don't you
I
get?
wasn't really paying attention to most of it. So
Oh,
that's
well.
why.
Does it? Can it be a left inverse and not a right inverse?
Yeah.
Well, here G is the right inverse of F. If you do F compose G equals I sub C.
Right.
So here G is the right inverse. We're defining what it means to be a left inverse and a right
But
inverse.
could you ever be one and not the other?
Yes, it can be one but not the other. But the thing of it is, but it's also possible for it to be both. If it is both, then it is called an inverse. So you just don't put the qualifier on there. If you don't put the qualifier on there, then that means that it's both a left and a right. So some inverses are both left and right inverses. In other words, they are just regular inverses, but some are only left inverse.
Conditional inverse.
Yeah.
No, they did. It makes the stuff move, but it goes straight up.
And the example that we gave was the apps and the
Right. Neg.
neg.
When do you go?
Okay, are we good?
Old school.
Is everybody clear on what's going to be on the test? Any more questions about what's going to be on the test? Okay, so shall we start review?
Proofs. They're all gonna be ones with like done on the homework, right? Or are you still putting on a rank?
You know, I don't think I'm going to put a random one because there's so much.
There's some
There is so much. There's so much. Yeah, and yeah, you're right. There is.
this.
Okay.
So that's why I'm telling you as much as possible. I want you not to be surprised on what's going to be on there. Okay. They were, but they're good. They put
Bring it all
They-
together.
put meat on your bones.
So we're going back to P dots.
Okay, so you want to go down? Okay, so shall we start with?
Tables.
Let's start with. No, I think let's get this out of the way. Let's get. You want to do a loop?
Yes, let's do it.
P dot.
Let's do the bit.
Oh, I see what you mean. Section P.
Wait, why don't we do the tables while it's fresh in our mind?
Let's just go in order, can't we? Okay, so let me see. What do you want to do? Shall we do the division algorithm? Is that what we did?
Yeah.
Shall we do the multiplication algorithm? Shall we review that, or you want to do the division? Oh, I know what it was. I know what it was. We did the multiplication algorithm, and I did an extra video. Remember? We came in here, a solo. I did an extra video solo of the division algorithm. Well, you want to do okay, it's shorter. Let's just do it. Let's just do the multiplication algorithm. So here's the multiplication algorithm. Q is 0 is less than or equal to n. And then IP gets 0, 0. And then the invariant P is 0 less than or equal to I, less than or equal to n, and P equals I times X. And then do, so here's the loop. And the guard is I is not equal to n. And the statement is I comma p gets I plus 1 p plus x. And then we end the do, odd, or ode, or however you want to say it. And then r, the post condition, is p equals n times x. So we assume that n and x are ints. Actually, the way we would do this is we would do int nxip, right? Is everybody clear on this? So we assume that n and x have pre-values, and we're going to make p be the product. Okay, so now how do you do this? And this is our loop invariant.
Prove P is true.
So first we have to prove that p is true before execute. Oh, and so here, notice that I put these letters here. Q initialization, P do, B, B, if B then S do, and then R is the post condition. So there's Q, P, and R. So I've labeled them like that. So the first, so you need to do these 4 things. So let's do these 4 things.
Prove Q initialization.
Prove P is true before execution of the loop. So you have to prove what?
We'll have the packet for this, right?
Yeah. So how do you do that? How do you prove you got to do that Hoare triple. How do you do the Hoare triple?
Definition of Hoare triple.
Well, but how do we, you don't have,
The stuff.
yeah, and you don't have to keep writing, you don't have to write down definition of Hoare triple. You just start right off, bang, do it real quick, because you're gonna need time.
Condition implies blah, blah, blah.
Yes.
Wait, what?
Well, blah, blah, blah implies weak precondition.
You do WP what? How do you,
WP.
because what is the Hoare triple? What does it mean for the Hoare triple for this?
Statement, and then the other stuff. Post condition.
Yeah, it's WP dot
Initially.
this dot this. You have to prove that this implies, you have to prove that what? This does what? You have to prove this implies what? WP dot,
IP.
WP dot this dot what? No, dot P.
Oh.
Are you with me?
Yes.
And you can just say P. You can just put P. You don't have to write it out. I put P here so you wouldn't have to write it out.
So do you want,
Good man.
Oh, that is
what do you want us to write out then?
You should start, the way you should start with A.
You have to say assume the condoms.
No, let's say that you don't even have to say that. You'll like that, won't you? That abbreviation. So you can just start off with WP dot,
IP
IP gets 0, 0, dot
P.
P. Okay, equals by what? Textual by, what is it? 9.18? What was the assignment statement? What's the, how do you do a WP with an assignment statement? What's the one that tells us how to do an assignment?
I think it's
like
14.8.
No, it's P point something. And textual, it's P point something and textual substitution.
PNT.
Yeah, it's P point 18 and so don't do P point 18 and then textual substitution, because that's going to take too much time. So just start with this, do this, and so what will this be?
We get P with blah, blah, blah.
Yeah, well, but let's do it. So what will we get? P with blah, 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 with this textual, what will we get?
0
0 less than or equal to 0 is less than or equal to n. So we'll get 0 is less than or equal to 0 is less than or equal to n. And what?
0 equals 0 times x.
0 equals 0 times x.
Math.
Okay, and then math, this will be true, and true will be
Drop.
just
So we
this.
can drop it, right?
And then this will be conjunctional meaning,
And then we have 0
And
is equal to n.
and we'll have 0 is less than or equal to 0, and 0 is less than or equal to n. 0 is less than or equal to 0 will be true, we can drop that. And then 0 less than or equal to n will be what?
True. Just a hard
Assume, and then at that point you say assume
Q.
Q, and that will be true, boom, we've done it.
Okay, that's a good one.
Are you with me?
So, on the left, 0 is less than or equal to 0 is less than or equal to n. What do we say to drop?
Conjunctional meaning, 0 less than or equal to 0, and 0 less than or equal to n. Conjunctional meaning.
Math.
And then 0 less than or equal to 0 is
We
true,
just
true.
say equals true by math for all of that, 'cause
No, oh, come on.
it's common sense. It really is.
Well, I know, but put in at least 1 or 2 steps here. You got it.
Math.
And now, what about P is a loop invariant?
True.
Now, what about, it's just another Hort triple, you guys. Yeah, yeah,
WS dot S,
yeah.
WP dot S dot P.
Are you with me? I don't think we need to go over that. I think you should do that. Make sure you know how to do it.
What is our B?
Oh, good question. What is our B?
Oh, it's in the do statement. Okay.
It's the guard.
Okay.
Are we good?
B stands for bodyguard.
Hey, that's good. B stands for bodyguard. And now what about D? R holds on termination. So now you got to prove what? P and
Not the guard.
not I not equal to N implies R.
What's C?
Oh, execution of the loop terminates. Yeah, how do you prove the execution of this loop terminates? Let's do that real quick.
You do with English stuff.
Yes, but how do you, what do you know? How do you know that this terminates?
IS equals.
I is increasing until it equals N.
But how do you know that it's not, if it's already greater than N, it won't terminate?
Because it's less than N due to the precondition.
It's just by the precondition.
By the precondition. Ah.
So that's kind
And each time you go through the loop, it goes up by 1. And furthermore, N does not change. You also have to note that if N was going up 2, then that might not work. Okay. Yeah.
So
We have another
that's
class.
pretty much how we prove it. We just say that.
Yes.
We're coming up.
Oh wow, you kept us a little late. Yeah.
Yep. I
Made up
demand
for yesterday, right?
refunds. And by that I mean extra.
No. I demand extra money because you're getting more for your money.
How about you give us more for our money on testing?